Yeah, this is Baba Hayath. I think so. Oscar already introduced me. So I am a principal engineer working at the Autodesk company. So I have a 14 years of experience. I am a passionate software engineer. I have worked in multiple companies like software-based companies and healthcare application companies like Philips, Siemens. So I have well versed with the design concepts like solid principles, design patterns, design architecture, system design, all those things. I am well versed with that. I have a deep understanding like how to make the requirements converting into the projects. So very much worked in R&D projects in all the companies. So I have pretty much a good background in the distributed systems, oops related projects, client server architectures, and coming back to the programming languages, I'm well versed with C++, C Sharp, and other languages supporting languages. So mostly I have worked in desktop applications. So that's all about me. So today we are going to discuss about GitHub Copilot for .NET developers. So before jumping into the GitHub Copilot, I will just introduce like how this GitHub Copilot got evolved, what is GitHub Copilot, and then we will jump into the Copilot and lot of demo session that I have planned. So going forward, we will cover all the Copilot related topics like how we can prompt and all those things. So how it started is like so you know that AI got evolved with the rule based engines. So earlier it was based on the rules, like based on the keywords that you talk. So based on that, that rule will get applicable, and then it will try to respond based on the rules. Suppose if I say for example, when you talk to the bank, like, right, so there will be a voice chat messages. So there you have to tell the specific keywords. Suppose if you are discussing about your credit card, you need to tell the credit card, so that the chatbot will connect to the credit card department. So that's a rule based algorithms. After that, the generation has moved on, and then it introduces a newer applications in the AI field, artificial intelligence. So if you take artificial intelligence, it's a big umbrella. Under that we will have a ML, machine learning. Under that we will have a deep learning. So deep learning, earlier it was not possible because of the computers and uh, it capacity to create the models. So now we have all the infrastructure, still it is increasing. So the deep learning has uh, become very popular. After that, NLP has started. NLP is nothing but natural language processing, means however the human beings are talking, that's a natural language, right? So English or any other languages. So how computers can process my language, because my words will be different and other people who talks words will be different, and the accent what we talk or how others will talk, but everything is different. So computer will started understanding the natural language processing. So that is how era started. After NLP, you might have used Siri or any other applications like Gemini, any other chatbots, Bixby from Blueberry, so BlackBerry, sorry. So these chatbots or these natural language processing has evolved, and it has started booming up. After that, the ChatGPT got introduced. So ChatGPT is general purpose trained model. So here you can ask any questions. Earlier it started with the charting. So you need to type so that text will be converted into the message, and then it will start generating the response for that. So there the era started with the generation of AI. It's called generative AI. So it's another smaller block inside the deep learning. So entire umbrella if you take, so generative AI is a new topic. Nowadays it's got getting popular. So it was earlier generating text to text. So after that the model got trained, and then it has evolved with the voice to text. So if even it is evolved to create the voices. So even it can mimic my voice. So those type of applications keep coming up, and it has evolved to read the videos also. So it can read the video expressions and everything, and then it can process that. So it can generate the newer video with my accent, with my expressions and all. So that is how the generative AI is popular with the chat GPT. After that, if you see that most of the chat gpt is used by the developers and engineers, right? So in software field, so if you see, developers will always ask for the questions related to the coding, right? So that is the way copilot has started. So copilot has started with github. GitHub, you know, right? It's a popular source control manager. Earlier, every open source projects are dumped into the GitHub repositories. It has a very good repository and source code management processes. So it has evolved a lot. So everybody from the developer community and engineers community, they started contributing to the open source projects. So there is a lot of code present in the GitHub, and then Microsoft has come up with the Copilot, which is trained based on the GitHub code base. So GitHub is like a trained model. GitHub Copilot is a trained model based on the code actually present in the GitHub repositories. It has read a lot of lines of code backed by the GPT. So GPT model it has used, and then on top of GPT 3.2 model, so GitHub source code also it has read, and then it has trained based on the coding programmers purpose. So that's why it is called Copilot. So this is a coding AI programmer for you. So going forward, we'll see all the demo related to the Copilot. Okay. So this is what about the Copilot, like how it is started, and if you see, it gives a real-time suggestions to you. Earlier, we used to have shortcuts. Suppose if I want to write a if I want to write a console write line, so I have to type console.writeline and all. So earlier, after Visual Studio IDE got updated, so in the IDE we used to write just a CW, so that it will, and if I click double tab, it used to write the entire line for me, console.writeline. So that type of shortcuts were there. It's like auto completions, I can say. So now Copilot will suggest you for auto completion also for whenever you are doing coding, and it will give a real time suggestions also when you are typing anything. So that is how you can use the Copilot. And benefits are like you can help, you can ask Copilot to optimize your code, so that we will see in the going forward. And you can learn new frameworks, and you can learn how to optimize the code, and you can introduce a more patterns, design patterns. So I will cover all these things in the later demos, right? So after that, if you see, it's very good trained on the C sharp, Python scripts, and everything, all the programming languages. So yeah, that's how you can start using this Copilot. So what is it best? What it can do for you as a engineer when you are coding? So it will write a repetitive task, a boilerplate code, like a redundant task like UTs and all these things. Unit testing. So unit testing is a one of the great measure to measure the quality of the code in each company. So we will have the software metrics, right? So one of the metric is code coverage. It means that how, if you write 10 lines of code, how much of coverage is there, so whether the unit test you have written, which is covering all these 10 lines of code or not. So that is how the unit test has evolved. The code coverage is a best metric to evaluate the code quality. And then uh, it will help you to debug and correcting the syntax. So most of the times we forget the syntaxes during the coding, right? Suppose link you syntaxes, or when any other syntaxes like task creation, async operations, all these things are like we will forget when you start coding, and then after few years you will forget the syntaxes, but you know the concepts. But this Copilot will help you to correct the syntaxes, and it will troubleshoot. It will be very helpful for debugging purpose also. So even if you have a unit test, you need not to compile the entire code. You can just simply test that unit piece of code, unit. So that's the most advantage of writing the unit test, so that there it will help Copilot to, in the best way. And if you want to summarize, or if you want to understand the existing code, so this Copilot also will help you in that area. And generating regular expressions, so this was a lot of headache earlier. So sometimes the expressions might not work for some scenarios. Suppose if you take email id validation in the UI side, so email id is a very complicated structure, right? So everybody can give their own keywords in the email id, so it's a bit complicated expression. So if you want to evaluate whether the email id is valid or not, so to write those test cases you need the regular expressions. So to generate the regular expression, Copilot will be very helpful. So going forward, I will just explain the what is the best practices that you can do in the Copilot. So most of you might have already used the chat gpt. So there you have a prompt engineering means how you can communicate with the chat gpt so that you will get the best answers out of it. So in chat gpt, if you see, you cannot directly jump to and ask the questions. Suppose if you want to write any method like a leap year function. So if you want to write the leap year function, when you are prompting, you can directly say that can you write a leap year function. So there you will get the answers, but that is not a best answer you will get it. So you need to understand the prompts, how you can give it in a better way. So for example, I will convert this into a best prompt. So you need to set the context for the chat gpt so that it will tune to that model, and then it will try to give the best answers. So you can simply say that you are the expert in c sharp. Can you provide me the, can you write a leap year functions with covering all the scenarios, corner scenarios, and the leap year scenarios. So then it will give the best answers to you, because you are telling and you are prompting to the model, ChatGPT model, saying that you are best at something, so that it will tune to the model of programming, and then it will give the best answers to you. So that is how the prompt engineering is there. So when you try to use a Copilot in your IDEs, which are integrated development environment like Visual Studio or VS Code or JetBrains, it is already integrated in all these platforms as an extensions. So Copilot, when you try to prompt it, you try to break the complex task into multiple chunks. So don't give the entire application. Like, can you create a bookstore application to me? So don't give that big complex thing. So try to break it down. Like you just give like, can you create a user session for me, user service? So something like that. You just break it down and you create a book catalog, all those things. So give the specific requirements so that it will give the best answers to you. So if you give multiple things, then it won't able to write the code for you perfectly. Sometimes it may work, sometimes it may fail, because it's a AI programmer for you. And you just give the proper inputs to it, what input needs to be fed, and what will be the output of it, so that it will implement very fast and it will give the best answers to you. And yeah, follow the good coding practices. You need to tell that every company has a different coding guidelines. So if you take C sharp coding guidelines, so every company has a different coding guidelines. So you need to feed what type of coding standard that you want to use, right? So all those things you try to keep in mind. So whenever you prompt it, right, so you use the tdd approach. Tdd is nothing but test driven development. So we will write the test first in this pattern. So after that we will try to do the development. So that is how the tdd works. Suppose if you see in this example, I'm trying to create a word search puzzle that everybody might have played. So don't give that, can you generate a word search puzzle? So it won't give the best answer for you. It will give some answers, but it is not best answer, I can say. So break it down into multiple chunks. Suppose if you see, write a function to generate 10 by 10 grid of letters. So that is one question you can tell. After that, once it generates, accept the answer, and then you move on to giving some more uh, requirements, like write a function to find all words in a grid of letters given a list of valid words. So something like this, like you keep giving the prompt and optimize that prompt so that you will get the best answer out of it. So try to follow the tdd approach. So tdd will try to give the unit test first, and then it will and then it will give the best answers to you. So let's deep dive into the C sharp. So I have just created a couple of concepts of C sharp, like language integrated queries like link queues. So I will show you the demo, like how link queues can be optimized by using Copilot, and a little bit advanced concepts in the C sharp. So let's jump into the practice now. So maybe I'll just zoom a little bit. So yeah, so how you can set up the Copilot is pretty much simple. So you can download the VS Code, and then you create the GitHub account. So once you create the GitHub account, sign up for the GitHub account, and then there will be a extensions tab here. So here you can type GitHub Copilot. So you need to choose this and install it. So once you install it, it will ask you to log in into the your GitHub account. So once you log in into your GitHub account, if you have an enterprise edition, then it will allow you to do it. Otherwise, it will give you the 1 month trial version. So you can see that all the documentation is provided inside this itself. Yeah. So you can chart. So there will be one more window here, like a chart window, like how you do it in the chart GPT. Similar to that, you can ask questions like and get the answers for this. But this chart is bit different. You can have a expert's opinion on this chart. So this is the inline chart. You can read about these inline charts. So this is how you can set it up the GitHub account. After that, so once you set it up everything, so you can create a new file. So maybe I'll just say sample.cs. Yeah. So once we start creating the file name, so with the extensions, GitHub Copilot knows about what type of language that you are using. So I will just use this. Sometimes you will in Windows you will find the Control I. So here it is Command I. So now you can ask the question here. Suppose if I want to write any query, suppose write a function, write a leap year function, and follow TDD. So follow TDD means it will start writing the test driven development first, means test cases it will start writing, and then if we accept that, we can start writing into the actual leap year code. So let me give this prompt. So you can see that it has created pretty much all the NUnit framework it has used. So it has created a leap year test. So first it is checking whether it is divisible by 400, like 2000 is a leap year and 1900 is not a leap year, but it is divisible. So 2004 and all these things. So it is not covered all the scenarios. Let's cover all the scenarios. I will just select this and then cover all corner scenarios. So it has written a separate file here. So let it cover everything. Yep. I'll just accept it. So you can see this, it has covered now different. So yeah. So this is a corner scenario. If I give the year as a 0, then it should be written that. So minus 400, this is not a leap year. So minus 100, minus 4, or minus 1. So these are all the corner scenarios it has enhanced. So now we have the pretty much good test cases. So now we can ask to create a leap year program. Write function. Write a function for leap year covering all scenarios. All test cases I'll just mention. So it will write exact matching of this. So you can see it has covered all the corner scenarios. Yep. So and then it has covered this. So maybe 0 and 40, 401 minus, all those things has not covered. So let me see how we can cover this. Cover all corner scenarios. Yeah. So this is how it will prompt. Okay. And one more thing what you can do is, suppose if it has created a NUnit framework, so you need not to do this boilerplate code, like it's a repeated code, right? Suppose if I want to convert this into XUnit, So in company wide, in organization wide, if the communication has started, don't use a N unit, try to use a X unit framework. So then you can simply convert by using this Copilot, convert to X unit. Sorry, typing. Yep. So it has converted everything into the X unit framework. So this is a very pretty much simple use cases that I have showed, like TDD, and how you can start prompting the questions, and you can keep optimizing it. So this is like a helper for you. It's not like a pilot. It's just a co-pilot. So you have to read the code and try to understand before submitting or going for code reviews. Yep. So this is all about one thing, and let's jump to another example. Like I have said, link you, right? I will just give an example. Like I have a list of students and students data, and I have to figure out the pass rate. So it has created a class, and then it has created a student database for me. And if we say the pass rate is 60, passing score is 60, so how many students has passed? So if you see that David is failed, Charlie is failed, and remaining three are passed. So it has already created a link queue. So what we can do is we can ask it to convert to normal query loop first, convert to loop, and then we can ask to convert it into a link queue. So you can see that earlier we used to write this type of codes. So now you can select this piece of code and ask for convert to link queue. Yep. So it has converted into link queue. Or you can ask like convert to SQL type expression. So link queue supports SQL type expressions. So let's see how it converts. Yeah. So you can see that it has converted from students, and then where the score is passing greater than or equal to passing score, get that entire selected one. So this is how you can keep optimizing your queries and all those things. And yeah, so this is one of the great example that link use. And let's jump to the some advanced concepts, like how you can use the a task, right? What I will do is I will ask Copilot to convert this into a method, and then I will try to execute it in a sequence. So move to a separate function. So let's see how it will move. Yeah. So it has moved to the separate function now. So calculate pass rate. Okay. What does it do? Okay. So it has moved to the separate function now. So now what we'll do is we will call this calculate pass rate in asynchronous way. So first I'll try to use the threads. After that we will see how we can use the task TPL library. Execute it in threads. Thread. Yep. So now you can see that it has executed in thread, so that it will go in parallel. So now I will just select this piece of code and I will make it async. So this is pretty much generic things that I am giving. So that's why it is promptly giving all the answers for me. So you can see that async API is created, and under the task it is getting created. Okay. So this is how you can keep giving the more things. And maybe I'll just use that one more prompt. So I will just delete these things. So now we can see like how we can use TPL library more effective. Create a process in async manner. Async manner. Okay. Async manner. Let's see how it generates. Yep. So it has created a process, running process in a async method. So this is how we can pass the arguments and then example exe. So it will start creating a skeleton for me, right? So one more thing what I can do is so I'll just select. So we'll see how we can use the more enhanced ones. So for example, matching, pattern matching and all those things. So I will just give like can you write a regular expressions, write a function to validate email id containing um, all special characters. So let's see how it generates. Yeah, so you can see that it generates the regular expressions for us. So it is looking for all the special characters, and at the rate after that it should be a dot, and then it continues, like it can be any domain. So this is how the regular expression started, and you can see the characters it is allowing, and after there will be a dot, and at the rate also it is looking for escape sequence. Yeah, so this is pretty much you can leverage for the pattern matching and all those things. So asynchronous programming has showed like how you can use a task parallel library async APIs so that you can see more enhanced ones. So for example, maybe I'll just say write a function to read from file, and function as one thread reads from file and another thread writes to file. So this is a pretty much classic example, like if one thread is writing into the file, another thread is trying to read from write to the file. So this is like a deadlock conditions when we if we not handled properly, or sometimes you will get a crashes because of the file handle is already opened in the write and read is failing. So to avoid that, the most of the time we use a consumer producer problem pattern. So let's see how it will write. Copilot, let's see. Okay. Process file async. Let me see what did it write. Yeah. Process file async. So there is one thread which is asynchronously reading all the file content. And where is the right one? Okay, write it into. Okay, so I'll just say follow. Okay, write. Okay, so you can see that asynchronously it is reading, and another thread is trying to write all the text directly. So I can say that convert to consumer producer pattern. So let's see how it converts. Yeah. So you can see that it has created a producer API and the consumer API. And producer is trying to read all the content, and consumer is writing the text. So this is how it works. So you will get the skeleton out of it. So this is how you can start leveraging the Copilot. So let's jump back to the presentation. So this is all about the C sharp, like how you can use the C sharp and all. So let's see how we can use for solid learning for OOPS and then solid principles. So pretty much everybody knows about the OOPS concepts, and it is understanding the OOPS concepts is very difficult in the programming world. So just a theory wise everyone knows about it, but when you come to the coding, so everyone will miss the OOPS concepts and the solid principles. So let's see how Copilot might help you for doing that. Suppose if I am trying to do some exercise, like okay, let me bring something. Suppose I'm trying to write a binary search. Okay, so write a binary search algorithm. So let it generate the binary search first. So everybody will start doing like this, right? So suppose if I give one more search, so most of the programmers will jump in writing this way. So this is clearly breaking the oops concepts as well as the solid principles, because if I introduce one more search, so this entire code base has to be changed. So that is how the oops concepts are sorry, solid principles are breaking, as well as we are not using any oops concepts here other than the class and object construction. So let's ask to create one more search. So let me, I will ask like write a function for linear search. So we have two functions now. So when I call this function, so here I want to choose the search algorithm based on the user's input. So let me delete this. Choose the search algorithm based on user's input. So if I say this, so it will I don't know what did I do. Okay. So so if you see that it is asking for the search algorithm, so if we choose one, it will be linear search. If we choose two, it will be binary search. So you can see that it has added the if else conditions. So as per the oops concept and the solid principles, this is not extendable. And if I introduce one more search, so it will again I have to come and change this. So it is clearly breaking the open close principle. I'm not going to cover the solid principles, you can go ahead and read about that. But it is clearly breaking the principles of design principles. So it is not extendable. So what we have to do is we have to do the interface segregation, and then we need to introduce a Elixir substitution principle. There are a lot of things that we need to do in this to make it maintainable, as well as to make it design compatible. Okay, so let's see how we can optimize and remove this piece of conditions. So I can say create a factory out of it. So there is a factory pattern, so we can leverage for this type of object creations. Create factory pattern for creation of such algorithms. So now if you see that the if else conditions will move to the pattern based factory pattern. So let me see what does it do. No, no, it didn't do that. Okay, discard. So what I do is I'll select everything, and then let's give the create an interface, search interface, and inject it in that using factory pattern, and avoid if else conditions as it's breaking open close. I can say just solid principles. So let's see, I have given the more things. So yeah, so it started creating pattern wise. So let me see this, accept everything. Okay, so it has created interface first, and it has exposed one API, and then it has all the classes. So this is a interface segregation sorry, interface implementation, interface way of implementation. So binary search also implementing the iSearch algorithm. So here if you see there is a choice of switch. So this is also, it is using, still using the search linear search and binary search. So this is not maintainable. Let suppose if I introduce one more search algorithm, it will break. So what I'll do is I'll just select this and introduce a factory for these objects. Create a factory pattern for these objects. So this is how you can keep optimizing the algorithms. So you can see that it has created a factory class and then moved the logic to here. So I'll just cut paste to outside. So you might have observed now, like it creates the instantly all the responses. So yeah, so if you see the factory class, it is looking for the get search algorithm. So based on the choice, it creates the objects. So in the main method, So we will replace this. So in the main method, you will just pass a choice, so that the clients who are using my algorithm, so my search algorithm factory, so they never know about what is the algorithms code behind we have written. So they will just know about the choices. So based on the choices, we this factory class will create an object. So this is a pure the dependencies we have removed. So now if I write the client side, if anybody wants to consume this, so they can start writing the UTs for this test classes. So this is how the oops and the solid principles you can leverage with the copilot. So this is one of the example. And then let's move on. So let's build the REST APIs. So I'm not going to cover what is the ASP.NET REST APIs and all those things. So I will just show like how you can use the Copilot to create REST APIs. So this will create a pretty much good what I can say framework for you. It creates everything with the standard manner based on your prompt. And it, so to create a simple REST API also you can use this Copilot. And routing and controllers, so this is the major thing. So sometimes if you take any web service, we forget to create the history API, or we forget to create a version API, right? So if I hit that version API, it should return me the what is a version of REST API that I'm using. So most of the time we miss that creating that API. But with this Copilot, it will try to start creating everything for you. An entity framework, I'm not telling how entity framework will be used, but entity framework will be used to decouple with the database, right? So if you have a different databases, so entity framework will create the model for you, and then you can connect to the different databases. So all the crude operations you can start doing in the and you can try to use the Copilot. So it's like all the basic framework you can start using the Copilot. So there are more advanced things that you can start implementing, like authorization, authentication, all these APIs. Versioning, I said, versioning is most complicated thing in the APIs. So you can start using this Copilot to create at least a skeleton for you, and then you can jump writing on this topic. So let's see how we can create the APIs now. Okay, so now we have an interface here. So maybe let's start asking to convert these what I can say. Okay, to expose this iSearch algorithm as an API. So let's select this everything. Uh, Convert iSearch search API as REST API. So I just gave this, and then let's see what and all. So it should start creating a controller for me, and then it should start exposing the REST APIs. So it's taking some time. Don't know what happened. Discard it. So let's prompt it again. Maybe I'll just delete everything. Create a binary search algorithm. Okay, so this is pretty much is created. Let me ask to convert this into REST API. REST API. Let's see what does it do. Yeah, it has started creating the controller for me, and then yeah, let it complete. Okay, accept it. So it has created a controller and API/controller. This is my API. So here you can see that in the controller base it has given the get API like binary search. So it is asking for perform binary search. So input is like you will have array and you will have a target. So what thing that you are going to search, and then it will perform the binary search. This is the same logic what we have used by 2 n by 2 logic, and then it will start computing. And this is how you can start adding to the REST APIs. So let me add one more, like can you add version API? Let's see whether it adds a version API. Don't know where did it add. Just change this to v1 here. Okay, so maybe I'll just ask like uh, add get API to get version. Yep. So this is how you can start using it. So it will start promptly, it will create everything for you, like it's said 1.0 version. So whenever I call the get API of this, it will return me 1.0.0 as a string back. So this is how things works. And maybe you can keep modifying it, like if you don't want to return the existing okay all these things, so you can return the customized things, all those. So one more thing what you can use it, like this is a REST API. So sometimes we use okay, let me write an example. This one, copy this. Okay, so I'm trying to create a find dates API. So what is this find dates, find all dates is like, suppose if I have an input, like I have a dentist appointment on this and book a club on this. So if you see this, the date formats are different here. So I wanted to write a regular expressions or any other pattern that I wanted to use to cover all this type of date formats. Suppose month is 02, sometimes 0 is missing, sometimes it's just 24, sometimes it's 2024, hyphens are there, slashes are there. So all these corner scenarios I wanted to cover. Let's see, first I will just say add the UTs first, add the, follow the TDD, I'll just say, or add the unit tests first. So let me see how it writes. Now it started writing, yeah. So you can see that it might be covering the pretty much all the scenarios. Yeah, find dates. So this is one of the example it has created. Yeah, find dates with different formats. So it has covered all the different types of formats, and then it is calling that into a different list. Yeah, this is one more corner scenario. Yeah. So this is how pretty much it has written. So you can leverage this to write this. And one more thing, so most of the time we use our own data types, right, in organizations. If some organizations will specify don't use the existing data types, try to use in built-in, or don't use the built-in ones, because any changes that we need to do, it has to be reflecting everywhere. So to avoid that, we can create our own string for this and replace it. So to extend this string one, we used to write the extension class. So let's see how it can write extension class for us. Write a string extension class and apply, I can say replace in date finder class. So let's see how it will work here. So yeah, it has implemented the string extension class, and then let's see, didn't replace, string extension, and then okay, so it has extended the just a string extension. So string will have exact extract dates. Where is that string? Input dot match. Okay, I'll just mention this, use this instead of all this stuff. Use string extensions. Yep. So you can see that it has extended the string extension, and then it has called the extract dates directly from the extensions API. So this is one more thing that you can start using it. Yep. So building REST APIs I have covered. So let's move on to the other topic. So software metrics, yeah. So this is a major metric to measure the quality of the code. Number one is a cyclomatic complexity. The complexity is like if you have the number of loops or if else conditions, so you will have a branches, number of branches and nodes, right? So based on that, the complexity will keep increasing. Suppose if I have a 3-4 loops, and the 3-4 loops will have a different type of complexity. It's so we have to break that complexity into a multiple chunks. So how we can optimize that? So suppose if you take the previous example, so we were using the for loop and then we converted into a link queue. So link queue will be with the link queue we will get better performances. So that is how you can leverage this and reduce the cyclomatic complexity in your code. So it will keep optimizing. Maybe we'll cover one demo for this. And number of lines of code. Yeah, so as I said, the optimization is always good, but sometimes so you have to review it very well. Otherwise, optimization, whenever we do optimization, it may introduce more bugs. So we have to be very careful. Even if you are using the optimize API from the Copilot, so try to review it thoroughly and write all the unit test cases before optimizing it. So that is the way to go. So this is also one of the metric to measure, because if you have number of lines of code is more, so maintenance is also more. So to avoid that, so you can keep optimizing it. And code coverage, we already covered. The unit test is required for covering that. So let me go back here. So let's write one complex algorithm. Maybe we'll say write a function with, I will say, maybe bubble sort with loop for loops. Let's see how it will write. Yeah, so you can see that the complexity is high here. So this is 1 2 3. So there are three ways it can go, and three, it will create nodes of three, so that the complexity is also three. So sometimes we'll call inside this, we will call another API, and then in that API again one more bubble sort, something like that. So the complexity will keep increasing for this API. So to avoid that, we can leverage this to convert into a link queue or something. Let's see how it will optimize it. So let's see, it has optimized, but it's not that optimized. Just added the conditions, corner scenarios. So we cannot optimize the bubble sort. Like maybe suppose if we have other things, so those things we can keep optimizing it. Maybe I'll just add, create a method to compute the max count of 3, max count of 3 from given array. So let's see how it creates. Max count of 3, max count of 3 elements, sorry, max count of 3 elements from a given array. This is like a little bit, no, it's not working. Discard it. I'll add one more time. The context is very important for this, because it's, we have written a bubble sort here, so it's doing this. Yeah, so you can see that if I have a given array of 1 2 3 4 5, something like that, so it is first doing a sorting, and then it is trying to append the first three elements. So how can we optimize this? So sorting is anyhow, so we don't want to use a sorting, because it increases the time complexity. So let me ask for optimize it. You can see that it has converted into one loop. So earlier it was used sorting, right? So if you use a sorting mechanism, it has a two loops. So the complexity is high there, cyclomatic complexity. But here we have only for each loop. So this, with this loop you will have only one loop. The time complexity is reduced here. And you need to have a corner scenarios like this. So corner scenarios, if I give the array size which is less than 3, so which is not expected for us, right? So we can add all the corner scenarios like this. So this is one of the example to avoid and reduce the cyclomatic complexity. Yep, writing unit test I have already covered, like how you can add more unit test cases. Yep. So best practices I can tell is like try to give the basic prompts, and then try to give all the inputs and outputs and break down the requirements like how we did it. So so that you will get a more usage of this. So you will get a best out of Copilot. So for example, maybe I will just show one memory leak in this one. um, I'll just show, write a function to open a file and don't close it. and let's leak the memory. Let's see what it generates. Sorry, I can't assist with that. Okay, I'll just type this one. Let's see. um, write a write a function to open a file and don't. Okay, let's see, write it. So it is already using statement, so the dispose is happening. Don't dispose, I'll say don't use using. Let's dispose it. uh, so we are calling the dispose here. Suppose assume that I am not calling the dispose, so I'll just remove this finally condition. So I'm creating a stream reader and I'm not disposing it. So in this scenario, the memory leak will be there. So let's see whether Copilot can help us in that, figuring out the memory leak. There is a memory leak in my code. Can you fix it? So let's see how it creates. Yeah, it's already figured out, like we are not using the using statement and it's not disposed. So it has used the using statement now and then it has disposed it. So with the using statement it has disposed. So one more thing what we can do is so with the c sharp dot 8.0 version, so we can leverage, we need not to use the using here like this. So I'm using so c sharp 8.0 version. So with this I just change this to this statement. So you can see that using has, there is no flower bracket, so now the cyclomatic complexity is reduced. So that is one more thing that you can use. So this is the concept used in C Sharp 8.2. If you are using C Sharp 8.2, you can simply specify using there. Okay, so that's all about the best practices here. And so don't use it for your core logics. So Copilot don't use it for all your core logics. So if you want to understand anything, so there are multiple things. So I can select like this. So this is existing code. I don't know how it is working and what it is doing. So I can just click summarize. So when you put slash here, so you can see all these things. So doc means it will create a summary for us. So let me show you that. So it creates a summary for me. So you can see this is a hectic job earlier, so now it has optimized a lot. So it creates a summary for me with the file summary. I can add I can keep adding the different methods or different APIs. So this is very helpful for docking purpose. And one more thing what I can do is explain, right? So if I click this, I can have a fix and I can have a test. I can just say explain. So what it does is it will pick up each and every line and it will try to start explaining for me what it is doing. So you can see that all the operations what it is doing. Try class, try catch block. The using statement ensures that properly disposed of once it is no longer needed. So this is what the statements, which is a good practice to free up the system resource. So this is how pretty much it is explained. So you can learn the newer things and you can keep updating yourself, not with the traditional coding like how we were doing in the using statement. So this is how you can leverage Copilot. And yeah, so this is a Copilot, as I already said. Don't think that it is going to be your pilot. So some YouTube videos that I have seen, like they have used the Copilot as a pilot. Sometimes it is possible, but if it is a critical projects, there you cannot make it as a pilot because it's very difficult if it is a critical path taken. So take it as a first code review for you. So when you are sending for the code reviews to your seniors or any other peer reviewers, so before sending it to the reviewer, you ask Copilot to review your code so that it will review and try to optimize whatever the code that you have written. And second advice what I can give is, don't think that okay, Copilot will do everything for me. So think in that way, like you need to understand the concepts first. So if you see all the demo that I have given, So I have to know the concepts first, like design principles, patterns, language based things, syntax, autocorrecting, all those things can be avoided. But the basic concepts, like how asynchronous APIs works, how the threads works, all these basic concepts we have to know first, so that we can prompt it properly and get the best results out of it. So that's all about the presentation. So over to you, Askar.